When we start talking about fractions, we have to remember a couple of things. The first one is that they are just simply representations of portions of a whole, or multiple groupings and portions of whole, depending on how we look at them. So when we look at fractions, and remember that they are just portions of a whole, parts of a whole, and we can also think of them as decimals. We can reflect the information in either method and still be able to get the same outcome. Now, one of the things that we have is we can use either decimals or fractions when we use them in different mathematical applications. Depending on what we're doing, one is going to be easier than the other. So, for example, when we're using fractions and we come to multiplication and division, addition and subtraction, we have some rules that we have to follow to be able to get to the final outcome of those. And out of those four base mathematical functions, multiplication, division, addition, and subtraction, multiplication is the easiest. Division follows closely up behind because we're going to convert it into multiplication. Addition and subtraction, however, are going to be a little bit more difficult, a little bit more involved, and they require a few more steps. But in the end, they're very, very easy to step through. So with fractions, we're going to take a look at multiplication of them first. So when we first get going, we are going to have some sort of a fraction. Doesn't really matter what it is. We're going to start off with a value of 3/7, and we're going to multiply that by another fraction, 4/5. Now, when we are working through fractions and when it comes to multiplication, the steps are very, very simple. We simply take whatever is in our numerator, the top values, multiply it together. And then, separately, whatever's in our denominators, we multiply those values together. So what we end up with is 3/7 times 4/5 becomes the same as having 3 times 4 in our numerator, and then in our denominator we have 7 times 5. So then we just go through and do those multiplications separately. So our numerator, 3 times 4, is going to be 12, and our denominator is 7 times 5, and that comes out to 35. So my answer of 3/7 times 4/5 simply becomes 12 over 35, or 12/35, however you want to look at it. And this is true for any type of fraction, as long as it's not a mixed, or as long as it's a mixed number and not a mixed number, an improper fraction versus the mixed number. So what we can do is, we'll talk about these a little bit later too, is the mixed numbers, we have a whole unit and then the portion or the partial left over in fraction form. A improper fraction is where we combine everything together, and essentially our numerator is bigger than our denominator. And we'll talk about that a little bit later. But either the way it goes is, when we're dealing with multiplication, it doesn't matter what the fraction is, we can multiply it together. If I have 11/10 and I multiply that again by, let's say, 4/5, the same process is going to be given. I take 11 times 4 on my numerator and 10 times 5 on my denominator, and I get 44 over 50. So even though I'm starting off this one with an improper fraction and a regular fraction, when I multiply them together, I get a standard, I don't have to do anything with it, type of fraction. This also works for whole numbers as well. If I have 3 of something, that is the same as 3 over 1. And I can multiply that by my fractions. So if I have 3 times 4/5, I have to remember, where's my numerator, what's my denominator? So when I go with a whole number, I have to remember that it's 3 over 1 instead of just 3. So then I get 3 times 4 over 1 times 5. And so then I end up with 12 over 5 for my final answer. So multiplication of fractions is very, very, very easy. It does not matter what we have on top, what's on bottom. We're just going to simply multiply them together. And then eventually, when we get to it, we're going to go through, we're going to simplify them down, see if I can find the smallest values that these will fit in, and so on and so forth. So same as we go through all of these, later we can go on and look and see if these are going to reduce any farther, but right now we're just trying to multiply them out. So one of the other things that we are going to look at is when it comes to division. So division can be somewhat complicated if you're not a fan of division. It's making something into smaller bits and pieces. And with fractions, it can look a little bit more difficult than what it really ends up being. So what happens is in division is we're going to take the two numbers and divide them into each other. So we're going to start off with 5/9 divided by a value of 25 over 18. So 25/18. So first off, what we're going to do is we want to write this in fractional form, because again, this division sign is just simply, let's create a fraction. That's all it's doing. So 5/9 is the same as saying I have 5 of something and I'm dividing it into 9 pieces. I have 25 of something and I'm dividing it into 18 pieces. And that's all that really fractions are doing. It's just a division sign between numbers. So when we look at it that direction, we can rearrange these numbers. So now I have 5 divided by 9, but then I have that quantity is then divided by 25 over 18. Now you may look right off the bat and be like, well, that makes it more complicated. Now I've got multiple fraction lines, I've got multiple divisions, and it's true, you do. But here's one of the cool tricks that we have, is when we are taking a fraction and we divide it by another fraction, creating a smaller fraction, we can do one of our little simple tricks that we have of one of our natural math rules that we have. So when we do a division of a fraction, we're going to take the entire value that's in the denominator, we're going to invert it, and we're going to multiply it by our numerator. By doing this, we are still maintaining the mathematical relationships of all of these numbers, but it makes it easier to work with. So my numerator, my 5/9, is going to stay the exact same, so 5 over 9. My denominator, I'm going to take and I'm going to invert it and then multiply it back into my numerator. So 5/9 is sitting there. My 25 over 18, I'm going to invert it. So that becomes 18 over 25. And then I'm going to multiply those across and do what I can do at that point. And then it's just simply a multiplication problem, which is really easy to do once we get it back into its standard form. So as we go through, we're going to go through and multiply these values. And right now, we're not necessarily going to simplify them out of the way. We're just going to let them go as they are. So the way that we do that is we take 5 times 18, and that's going to give us a grand total of 90. And then my denominator is then going to be 9 times 25, which gives me the answer of 225. And one of the things we want to look for is when we're going along the way with this, we can simplify on our way out. And again, this is another concept that we're going to talk about later when we get into these. But when I'm doing a division problem and a multiple step division problem like this, is I want to figure out what do I have that's going to be taken out of this equation? What do I have in top? What do I have in bottom? What's in my numerator? What's in my denominator that can get canceled out? So if I look at this, I've got a 5 and a 25 on opposite sides of my divisor line, my fraction line. So I know that 25 is 5 times 5. So if I was to split these up a little bit, I would have 5 times 18 over 9 times 25 is where I'm starting with. That's going to translate into 5, and then this 25 down here is going to split up into 5 times 5. So I can kind of start factoring out a little bit and even doing some pre-division on these to find out what's going to cancel. And now that I have a 5 on top and a 5 on bottom, and they're all being multiplied together, those are going to cancel each other out and leave behind 1 over 1 for that section of the problem. My 18, if I notice, also can split up a little bit very easily with my 9, and I can get rid of that. My 18 then becomes a 9 times 2. and my 9 just stays down there on the bottom, and now I can get rid of it in the same step. So then I go through and look at what I'm left with after I've simplified this as I'm going through, as I'm cross-multiplying all these things. And so I end up with my numerator being 1 times 2, and that's divided by 1 times 5. And so this fraction just simplifies itself down through the steps of multiplication and division all at once. I end up with 2 over 5 as my final answer. Now, in all sense of these two are equivalent fractions. They are just not in their reduced or lowest form. And the reason that we want to use values in their reduced or lowest forms is when we start getting into more complicated functions, more complicated problems where we have big numbers already that we're working with, anything that we can do to make these smaller is going to be beneficial to us in the end, because then at the very end we don't have to go back through and try to refactor a ginormous grouping of numbers versus if we took care of it inside the steps as we went along. Now, as we do that again, it's going to make our life easier, we're going to be happier, and it's just going to make our numbers not seem so huge in the end when we go through and save for them. So again, division, it's really simple. We just put our division as a divider, as a fraction line. We write our two fractions on top and bottom. Then we take our denominator, whatever is there, the entirety of the denominator. We invert it and then multiply it back to our numerator. So again, the 5/9 carries over. The 25 over 18, we're going to invert it, which means they change places. So then it becomes 18 over 25. And then we just multiply numerator times numerator, denominator times denominator. And also as we go through, we find the ways that we can kind of reduce them as we go and make it so it's not such a big number. And this can work again for any kind of fractions. So if I had 5/9 and I was going to divide it by, let's say, let's go with 3, okay? When I convert that over, I'm going to have 5/9, my divisor line or my fraction, which is 3, and again, remembering that 3 is the same as 3 over 1. So then, if I apply the same concept, my denominator, this 3 over 1, is going to invert, and then we're going to multiply it times my numerator. So 5/9 is then going to multiply times 1 over 3, and then I end up with 5 times 1 over 9 times 3, and that's going to equal 5 over 18. Now, this is the lowest that this value can get because there's nothing in here that's going to cancel out when we have the same number being multiplied in a division problem as well, because multiplication and division are opposites.